Welcome students, welcome again to my new lecture. I am Mohammad Tanvir Ahmed, lecturer at Department of Civil Engineering, World University of Bangladesh. Outline of the lecture. In today's lecture, we will cover the following materials. Number 1, three-phase system of soil. Actually, this is the structural arrangement of soil which consists of air, water and solid particles. Then number 2, composition of an unsaturated soil. That means composition of soil whose void space is not filled by water. Then physical properties of soil. That means density, water content, specific gravity, etc. Depth of water in soil and volumetric water content. Actually, volumetric water content means water present in soil based on its volume. And the last one, classes and availability of soil water. Three-phase system of soil. A soil mass is a three-phase system consisting of solid particles, which is also called soil grains, water and air. The total amount of water and air is actually the void space. So, the void space between the soil grains is filled partly with water and partly with air. However, if we take a dry soil mass, that means which has no water or moisture content, the voids are filled with air only. In case of a perfectly saturated soil, the voids are filled completely with water. In general, the three constituents of soil do not occupy separate spaces, but are blended together, forming a complex material. But for calculation purposes, these three constituents are considered as separate, as shown in figure into the next slide. This is the three-phase system of soil. This is air content, this is water content, and this is solid content. Here, this part is with respect to the volume. Here, VA represents the volume of air, VW represents the volume of water, and the sum of these two represents the volume of voids, that means VV, and VS represents the volume of solids. VT is the total volume of the soil particle. This part represents the mass of the constituents. Here, MW represents the mass of water, MS represents the mass of solids, and MT is the total mass. We know the mass of air content is 0. So, this contains Ma, that means mass of air, will be 0. And all the symbols have illustrated here in this slide. Here, the three-phase system has illustrated broadly, and some relations has also built up. As we know from previous slide, this is the three-phase system of soil. Here, this is air content, this is water content, and this is solid contents. This side represents the volume, and here some relations among volume has built up. We know that VA is the volume of air, and we can calculate the volume of air using this equation. We know that air content Na equal to volume of air divided by total volume. That means how much air stored in the total volume of soil sample is the air content. And from this relation we can get Va equal to Na into V. And this is the volume of water, Vw, and Vw can be calculated using these two equations. And from the relation of water content, we know water content Nw equal to volume of water divided by total volume as similar to water content. And from this relation we get volume of water VW equal to NW into V. Similarly, we can also calculate volume of water using this equation, and here S represents the degree of saturation, and we know that degree of saturation is equal to volume of water divided by volume of voids. That means how much water presents in the total voids of the soil sample represents the degree of saturation S, and from this relation we get VW equal to S into VB. And this Vs represents the volume of solids. Here the sum of these two volumes, that means volume of air and the volume of water, represents the total volume of voids, and the volume of voids can be calculated using these two equations. Here first equation VB equal to N into V. N represents porosity, so when porosity will given we will use this equation. We know that porosity N equal to volume of void divided by total volume. So from this equation we can get VB equal to N into V, and the other equation is VB equal to E into Vs. Here E is the void ratio, so when void ratio E will given we will use this equation, and from the relation of void ratio E we know void ratio E equal to volume of void divided by volume of soil particle. So from this equation we can get volume of voids VB equal to E into Vs, and this V represents the total volume. And this side represents the mass of the constituents, and here some relations has also built up. This is the mass of air Ma, and the value of Ma will be 0, and as we know the mass of air content is 0. Mw represents the mass of water, and it can be calculated if we know the water content W. We know water content W equal to mass of water divided by mass of soil particle, and from this equation we can write Mw equal to W into Ms, and Ms represents the mass of solid particles and can be written as density of dry soil, that means density of solid particles into total volume. If we multiply these two terms we can get the solid particles, that means the mass of solid particles, and M represents the total mass, and we can calculate the total mass using this equation M equal to rho into V. Here rho is the density of the solid particles, rho, that means density of soil, and V is the total volume. So in respect of mass we can calculate total mass M equal to sum of these three, that means Ma, Mw and Ms. And with respect to volume we can say the total volume V is the sum of volume of voids and volume of solid particles. Again this volume of voids can be written into two, that means volume of air plus volume of water. So total volume stands Va plus Vw plus Vs. Composition of an unsaturated soil sample. This is the composition of unsaturated soil sample. Unsaturated soil means the soil which is not completely dry or whose void space is not totally filled with water. So in unsaturated soil sample, there exists water content, soil particles, and air. We can see here is the picture that represents the individual components of unsaturated soil sample, and here mineral and organic matter. These two represents the soil particles or solid particles. And this is air and this is water. These two, air and water content, combinedly form the pore space. Soil physical properties. From the three-phase system of soil, we can see that M equal to mass of air, that will be always 0, Ms equal to mass of solids, Mw equal to mass of water. And this term in respects of volume, Vv equal to volume of voids, Va equal to volume of air, Vw equal to volume of water, Vs equal to volume of solids. So total volume of voids Vv will be volume of air plus volume of water. That means the sum of these two items or two terms. This is the unsaturated soil sample. That means this soil sample is called the bulk soil sample, and the volume of such unsaturated soil is called the bulk volume. Now, if we symbolized porosity as phi, we can get phi, that means porosity equal to volume of voids divided by Vb, that means bulk volume. Similarly, void ratio eta will be volume of voids divided by volume of solid particles, and degree of saturation S will be volume of water to the volume of voids, and degree of saturation may be from 0 to 1. If the total void space Vw is filled with water, then the saturation value S will be equal to 1, and if the void space has no water content, that means in case of dry soil, Vw, that means volume of water, will be equal to 0, and so degree of saturation S will be equal to 0. Here this is Vv, that means bulk volume. Bulk volume, that means this total volume. So bulk volume Vv equal to Vb plus Vs, volume of voids plus volume of solids. We can also write bulk volume Vb equal to Va plus Vw plus Vs. That means volume of air, volume of water, and volume of solids. Mass and density. Specific gravity of solids rho p equal to mass of solids divided by volume of water. As we know, specific gravity is the ratio between mass of particle divided by mass of water of the same volume. So if we multiply the density of water with the volume of solids, we will get the mass of water with the same volume of mass of solids. As we know, rho W, that means the density of water equal to mass of water divided by volume. So we get mass of water equal to rho W into volume. So this volume will be equal to the volume of soil particles. Now, specific gravity of soil particles may vary from 2.65 to 2.7, and more specifically we can say the specific gravity of mineral soil is equal to 2.65, clay soil is equal to 2.7, and organic soil is equal to 2.6. Mass and density. We know bulk density rho v equal to mass of solids divided by bulk volume of soil. We know that density rho equal to mass m divided by volume v. So from this relation we can say the density or bulk density rho v equal to mass of soil solids divided by a bulk volume. Now apparent specific gravity AS equal to bulk density of soil divided by density of water. We can also write this as mass of solids divided by mass of water, and if we multiply the density of water with the bulk volume of soil, we will get the mass of water. And we have seen this equation in the last slide. Mass water content. The mass water content theta m is equal to mass of water divided by mass of dry soil. We can also say the mass water content is equal to weight of water divided by weight of dry soil. The process of calculation of water content has shown in this figure. Here, this is the weight of wet soil. That means this weight includes weight of water, air, and soil. This is the dry weight of soil. That means this weight includes only the weight of air and soil. And if we subtract this dry weight of soil from the wet weight of soil, we will get the mass water content. Relative sizes of soil particles. Here, the sand particles ranges from 0.05 to 2 mm. The silt particle ranges from 0.002 to 0.05 mm. And the particle which is smaller than 0.002 mm is termed as clay particle. Volumetric water content. That means volume of water present in soil sample. Volumetric water content can be calculated using this equation. Here theta v, that means volumetric water content equal to volume of water divided by bulk volume. With the same process as mass water content, we can calculate the volume of water content. The only difference is that we will take the volume of the constituent instead of the weight. This is the apparatus used to determine the mass water content. Here, this is the wet soil. After taking the weight of this wet soil, it is kept in an oven for 24 hours to dry. After drying, the sample is again weighted. The difference between the two weights is mass water content. Volumetric water content. We know volumetric water content theta v equal to volume of water divided by bulk volume. Here, volumetric water content equal to Vw and bulk volume equal to Vb. So theta b stands Vw divided by Vb. Now we know a density of water rho W equal to mass of water divided by volume of water. From this equation we can write volume of water VW equal to mass of water divided by density of water. Similarly, we know bulk density equal to mass of soil solids divided by bulk volume. And from this relation we can write bulk volume VB equal to mass of solids divided by bulk density. And if we replace these two equations VW and VB here in this equation, we will get theta V equal to MW divided by rho W divided by MS divided by rho W. And we can also write theta V as theta V equal to MW by MS into rho V divided by rho W. And we know MW divided by MS, that means mass of water divided by mass of soil solids equal to mass water content theta M. So theta V equal to theta M into rho B by rho W, rho B by rho W. Depth of water D in a soil layer. As this is a circular shape, so we can calculate the bulk volume VB equal to area into total length. Area of circle is equal to pi r square and length is L, so VB equal to pi r square L. And water volume VW equal to pi r square, that means cross sectional area of the circle, pi r square, and this D is the depth of the water content, so volume of water stands pi r square D. And here D equal to theta V into L, that means volumetric water content into length of the circle or length of the sample. Again we know volumetric water content theta V equal to theta M into rho B divided by rho W from here. And we know rho B by rho W is equal to apparent specific gravity, which we have seen in the last slide. So finally we can write volumetric water content theta V is equal to theta M into AS. That means volumetric water content equal to mass water content into apparent specific gravity. Example of soil water properties. Let's read the question. A field soil sample prior to being disturbed has a volume of 80 centimeter cube. That means volume VV equal to 80 centimeter cube. The sample weighted 120 grams. That means this is the weight of soil. After drying at 105 degrees Celsius, the dry soil weigh 100 grams. So this is the dry weight. What is the water content by weight? That means we have to calculate theta M. What is the volumetric water content? That means we have to calculate the theta V. What depth of water must be added to increase the volumetric water content of the top 1 foot of soil 2.3? That means the depth of water content. So we have just picked the data from question and arranged here. Soil sample volume VB, that means bulk volume equal to 80 centimeter cube. A dry weight of soil sample MS, that means mass of solids. So dry weight is 100 gram. And weight of soil sample, that means mass of solids plus mass of water equal to 120 gram. Here 120 gram. So we have to calculate the following three items. So our first term is to calculate the water content on a dry weight basis. Now we know theta m, that means water content on a dry weight basis, equal to mass of water divided by mass of solids. Here mass of water equal to 120 minus 100 equal to 20 gram, as 120 is the wet weight of soils and 100 is the dry weight. So the difference of these two is the mass of water. Now theta m stands to 20 gram, as weight of water equal to 20 gram and mass of solids equal to, that means mass of dry soils equal to 100 grams ms. And finally theta m stands 0.2 gram of water per gram of soil, that means 0.2. Then next one is theta v, that means water content on a volume basis. We know theta v equal to volume of water divided by bulk volume. More precisely we can write theta v equal to rho b by rho w into theta m. Here we know rho b, that means bulk density, equal to mass of soil divided by bulk volume. So ms equal to 100 gram and bulk volume equal to 80 centimeter cube, and substituting all these values we get bulk density rho b equal to 1.25 gram per centimeter cube. And we know the density of water rho w equal to 1 gram per centimeter cube, and replacing all these values here in this equation we get water content on volume basis theta v equal to 0.25 centimeter cube. The last one is depth of water d. Here current depth of water in 1 foot of soil d equal to theta vl, as we know the depth of water d equal to theta v into l, and as the depth of soil is 1 foot, so this length l equal to 1 foot, and theta v we have just calculated here 0.25. So finally here theta v equal to 0.25 and l equal to 1 feet, that means 12 inch. So d stands 3 inches of water. Now the depth of water in the soil when theta v is 0.3, as we have to increase the value of theta v as 0.3. So when the value of theta v is 0.3, then d stands d equal to theta v into l. Here theta v equal to 0.3 and l equal to length of the soil, that means 1 foot or 12 inch. So depth of water stands 3.6 inches of water. Thus the depth of water to be added is 3.6 minus 3, which stands 0.6 inches. So we need to add 0.6 inches depth of water. So that is the end of our today's lecture. Thank you everyone.